Hello and welcome. I'm Bill Wake. We're working on a basic interpreter written in Swift, and we've come a fair ways. At this point, we're ready to start working on functions, and the one we're going to start with is def, which creates user-defined functions. All right, so def looks like this. You say def, and then fn, and some variable, which is a through z, or it's not really a variable, but part of the name. So we're defining fna, fnb, and so on up to z. And you can take an argument. I don't know if you can take multiple arguments, but you can declare a variable that you're going to as a parameter, and then on the right-hand side of the equals, you create an expression. And when you encounter this at runtime, you pass in the parameter and then get the value back. Okay. Notice when that happens, you're creating, it's kind of a new context, right? Because you have a whatever scope you had, but now you have this parameter added in. And we'll look at, that's going to create some issues about when we have multiple functions running around. So we'll look at that. I also think we're going to do some standard built-in functions, and maybe when we do function calling, it's easier to start with one of those. So we might do that, but this will be a fun run, I think. All right, now I've used this picture many times. It's we're making an interpreter, and interpreters look a lot like compilers on the front. So you feed in program text, it runs through a scanner process that creates a stream of tokens. So a name like variable x9 is its own independent token. A reserved word is a separate token, so def in our case. And then you feed that through syntax analysis, which is also some semantic analysis, and it creates a tree of nodes. Then in a compiler, you would go generate code from that tree. In an interpreter, you just kind of directly walk through the tree and do one step at a time on the tree. Input, output, it's a running program at this point. Okay. We've done the lexical analysis for def, and we're just about to do the syntax analysis. I think when it comes to interpreter, I might, well, I don't know that there's any interpretation per se. Interesting. We'll have to think about that one. But when it comes to function calls, there's definitely an interpreter involved. Okay, let's see where we are. All right, so we left off with a failing test last time. The test is define function d of x equals x. Actually, I'm going to call it function I for identity. I was going to make it d for double, but I made my expression simpler. All right, so you feed that in to the parser, and we expect this tree back. It's a result. It's got line 25, some sort of def thing. I don't know if this should be, it may be we want this to be function I. That's the name you're going to use when you call it. So maybe that's what we're defining. I'm treating the fn as a keyword, but the real name, when you use it, it's fna or fni or whatever. The variable it uses is x, and we expect variable x to come back as a float, because if it were a string, it would have a $sign in it. And then we're asserting that there are no errors in that process. Now, what we have right now, we just got skip, which is just sort of a bailout kind of thing. And we failed our assertion there because it says error missing target. All right, now I think we started our method. There it is. Okay. Yeah, so here's define. It eats the def. It's already eaten the line number. It eats the def. And then rather than do anything more, we just stopped here and threw an error. Okay, so, I've needed this already more than once, not yet implemented. Let's add that to our parse errors list. We have it probably a few times, and let me find one more. I think, yeah, that's not really yeah, so we're just returning some empty program is skip. No line number. Okay, statement down here. Unknown statement. Okay, fair enough. All right. I'll run this again just to confirm I got my not yet implemented. starting slow. Okay, there we go. Skip and not yet implemented. All right. And down to our define again. Assign define. Okay. So with the parser like this, we should see an fn next. Okay. So basically we have a require here that checks that. So we require fn, and the error is user defined function starts with fn. Okay, and that's a new error. Actually, it's really must start with fn. Okay, so we will get the fn, and since it's there, we'll consume it. So next token. Okay. And then we need a variable. Oh, I gotta make sure that's the way enums work. I can't really do it that way. Okay. Let's do it this way. Guard. I've done it before. Guard case, yeah. Case variable let name equal token, else that. So if it's not, if it doesn't start with a token, if the token is not a variable, then we want to throw an error. Parse error dot def requires variable after fn. And you know, if we were going much further, we really should turn these into somewhere somebody would turn these into real messages, but for now we're not worried about it. What's going on up here? Okay, that's a weird positioning, isn't it? Okay, so the deal is now we have name. All right. So if our thing is not a variable, as it is required to be, like I here, then throw an error, and then we consume the token. Okay, always got to do that. All right, now we also have the name. Okay, and we have a requirement there as well. So the name is only allowed to be a single character, which implies you can't have string functions too, by the way. All right, so we'll put the semantics in. If name.count is not 1, then throw parse error dot user defined function name. Well, how do I want to say this? It's that must be fnx. Fn followed by a single letter. And so I'm pretty much trying to be pretty specific on each little possible error. Let's see. Okay, so if the name count is not 1, then we got an error. All right, so we're we're up to the left parenthesis. Okay, this is another require. Hello, yeah, it's Memorial Day weekend coming up here, so yeah, nice to see you. Let's see. So, and I'll probably still do Monday's show. I don't think we're doing anything fancy. It's gonna rain here. Okay, so we need a left parenthesis. Okay, and let's say def requires left parend before parameter. Okay. I'm surprised this thing is generating so many messages, though, I have to say. Okay. We're going to be slightly invaded here. Okay. So we've got our left parend, and let's consume it. I'm going to add to my list. Require should just do the next token as well. It's a very common pattern. In parser, require should consume token. Okay, now let's see. We're up to another variable, right? We need a parameter, and I think let's find the definition in here. Def function a variable. I think it's implying it's only one argument. And let's see if we can find it in here. I think a little bit of a it's funny how little like summary there is in this. Okay, there's this. Okay, so 15 statements in kind of random order. So function letter, unsubscripted variable equals expression. Okay, so one variable. All right, so well, let's see. We're gonna have to do this guard thing again. Okay, def requires parameter variable. Okay. Parameter. Okay. So notice we're accumulating information too, but okay, so we have the parameter variable. Let's see, go back here. Okay, now we need to write parenthesis. And another try require. Oh, goodness. Okay, so this is a right parend. Requires right parend. After parameter. And it's this thing is such a linear, it's just got required. But it's the way it goes. Okay. All right. Now we have a require a right parend. We need an equal sign. Requires equal. after parameter. It's kind of crazy. I mean, most we got half our error messages are about user-defined functions. Okay, I'm going to change the name and be consistent here, though. Sorry, while I'm doing that. Let's call it def. Function must start with parameter. Consistency is not my strength here, is it? And really, I'd be better off if I weren't mixing my refactoring with my implementation, but I guess if I'd written it right in the first place, it wouldn't be an issue. Okay, go left paren, variable, right paren, equal sign. Okay, now we're ready for the expression, and it'll do its own error checking, so we are off the hook there. Okay, and our function should say throws, right? Okay. I mean, my goodness. Okay, try let. I guess I can. Okay. All right. So now we've matched all the pieces, and we just need to return the thing we're doing. Okay. So this is a def. Return def. First string is the variable, so it's function plus variable. No, what do we call it? Name. The next one is the parameter, and the third one is the expression. All right. I guess I can run that here. And expect to pass. All right. Let's get all those. And really, I really should have test cases for all these failure cases too. Let's do that. Yeah. Well, let's get an error case. Check error. I think that's close to what we want. Okay. Okay, so first one, def must start with function. Okay. Oh, this is no variable. I don't know how many we got. Okay, next one, function is a single letter. Now this one's funny. I don't know if this is detectable this way. We'll see. We may have to do something other than a letter there. Okay. Thing X requires parameter variable, right parend. Well, let's make the mistake I would make. Oh, that was it. Okay. I expect all these to pass except that one I said might not. This one, 400. One failure. Oh, it wasn't the one I expected. Requires variable after function. Def requires variable. Oh. I probably should have started from a working one and then added them in. Okay. Oh, good. All right. Yeah, so those aren't really test driven. I guess I could take one of these out and just make sure that I'm doing what I think I am. Just so we get one failure. Yeah. Requires equal after parameter. Okay. And yeah. Okay, yeah, so expression caught that there was a mistake, but we wanted to be more specific. All right. Let's run them all. And user defined. Sorry, my English grammar there. User defined functions with def. Parser only. All right, so now we have this, and it's just kind of sitting around. Like, how do we interpret it? Well, it's gotta change somewhere. We have to store this expression that it's the variable x there, right? It's because we want to, when we want to call it, we're going to have to evaluate the expression. Having it in the form of the tree seems right. All right, so we'll just talk through interpreter and then see what we got. So what happens when you define it? Well, so far we just do nothing. But I think what should happen, I mean, we have to store this somewhere because the interpreter is going to read the line and do something and then go on to the next line. It's not going to keep that around unless it puts it somewhere. And I think what we are looking at is our symbol table is the right place to put it. Now in less dynamic languages, that would be a compile time kind of thing that, you'd stick it in the symbol table, you'd stick a function definition somewhere and then call it. With this more dynamic one, the function doesn't really get instantiated until, doesn't really get called until it's, time to use it. So we just have to make sure it's kicking around. Now we're store. Okay. So I think one of the things that we want to store, I don't know, maybe a function is a value as well. And so when you see a reference to function I being called, you go in the store and say, "Give me function I," and then you call it. I mean, you'll have to do some work with the variable, but you call it. All right. So let's look at storing it. Okay. So our value, and it's kind of funny because like, we don't really have a lot of functions. Now, we also have these system defined functions, and I want to make sure we accommodate them as well. So that's why I'm kind of tending to defer this, but I'm somehow imagining there's another case that's like function, and I don't know if there's another object for functions because they all have different parameters, and some are string and stuff like that. They have their own type basically. In any case, there's a value that's that, and we're going to look that value up in the symbol table, get the expression on the right-hand side, modify the environment to take the parameter, and then evaluate it and go from there. Okay, so we'll defer that one. All right, so we got expressions. I'm going to be more explicit here. So functions. Okay, so user-defined functions. Okay, so we parse them. We've done that. But evaluate. Well, no. Interpret, which is save the value. Okay, not done. All right. So I'll take this. May's almost done, my goodness. Okay, and so that one's done. This is system functions, predefined functions. Okay, and function calls. I think that's the other thing. This one's not really an expression, is it? It's more like def. So def. Okay, so parsing is done. All right. Let's see these user-defined functions. We'll pick the easiest one we can find. Okay. Absolute value. That's nice and easy. Int of x, random x, sine of x. Sine, cosine, square root. Well, that's a good classic. Okay, and notice all these are also functions of one argument that return a number. So they're number to number. When you get the string ones, it gets complicated. You get multiple parameters and stuff like that. All right. So, what? Okay. And we're faced with a choice. Like, do I want to, when down at the token level, do I want to have a function for abs and int and rand and so on? Or are they all kind of a predefined function with the information that it's abs and so on? I don't know. It might be easiest to make them separate. Okay. Yeah, so if I left them keywords, that's... I don't know, what would I put? I guess I'd put the string. Yeah, maybe the string and the type. I guess I'm just dealing with the references, right? So maybe, I guess what we're doing is function calls. All right, so I'm going to give a function call, y equals abs of x, or y equals square root of x. Let's get the grammar right for that. I don't know what. I guess function. Yeah, I don't know. Maybe the way I parse the functions isn't the best. We took the fna and we said let's look for the keyword fn and do that, and then but when we're calling it, it's going to look like fn. Okay. So our grammar. All right. So we're back to let's see. Can we find a function call example? Not really. No. How about over here? Got three basics worth of definitions. No functions. Okay, I don't know. Let's see, expressions. There's some. Okay. Right. So it looks like a function call looks like function and then parentheses. And the function could be one of these. It can be fna. Let's go back to this tokenizer, lexer. There's fn. Let's see how this thing maps. Okay, so keywords and names. Okay, so we find it, we look for a reserved word. If the reserved word is a remark, maybe I should do a return. Yeah, maybe fn should be, we should say, oh, the keyword's fn, and like remark, we have extra work to do. We want to find the letter and then maybe return that as a function. Okay. Right. So let's go do some testing. Okay, and we're just going to start with that square root. Okay, so test a function call with square root. I think, yeah, we'll establish that we don't know the name there. Okay. Oh, so I should be able to just say check token, I guess. And it's only taking the first token. What do we expect to get? Well, I think we expect to get, let's see, what do we expect? There's a token. I guess we expect a function name. Is it a system function? I'm not sure the right thing to call it, but it's really a PDF, a predefined function. Oh, let's see. Let's just call it function. Well, no, we have that already, don't we? Let's call it function fun of, and then do I want that? Maybe it's a predefined. Okay. So That is so predefined. So we're gonna call these all predefines. Okay, I guess that's a starting point. And our token, we need to add predefined with a string. Okay. And I think that should do it. And this should fail, of course, because we don't do anything with it. All right. Came up with a variable s because we only have one letter names unless you use digits. And we did not get the predefined token. Okay, so lexer. Let's just add it in there. I think I'll put it in after all the standard keywords. Square root is predefined square root. Yeah. Okay. And that should be fine. All right. The parentheses we already matched, the number we already matched, that's all good. We'll backfill all the others shortly. I want to do more of the grammar side though. So to do grammar down at the bottom. All right. So we have factor, number. This is really function name. So I think we would say predefined for now. And it's expression. We don't need to worry about the commas yet because we don't have any functions that do that. Okay. And we require a left parent and then expression and right parent. And this is not optional. Okay, so we're doing the system one first and deferring our user defined. All right, the parser. Okay, so down in factor land, we have yet another possibility. Term power factor. Yeah. Factor. So it could be a left parent, it could be a number, and it could be a function. All right, so we'll make a test. Okay. Let's do one of these. Is this predictable? I don't know. We pass in this. This is this string in the result. Okay, we're gonna clean up that. At least write a check function that looks like this. Okay, so in our case, we're saying y equals square root of 4. Actually, it's print is probably a little simpler. Oops, print square root of 4. Line 25, this is a print. It takes an array of values. And this is, I guess we need a new thing, don't we? I guess we're going to need a predefined here as well. Could be a variable, could be a predefined function, which is a string and an expression. And we may need to do the type in here at some point. I'm not quite sure, but all right. So here we expect a predefined. The string is SQR. The function is a number of 4. 25 print, got an expression. I believe that's okay. It will obviously fail. Let's put something in for now. Okay, I'm gonna hard code that for now just to get through here. Interpreter, yeah. Okay, again, just getting through. Okay. Skip, yes, but we get an error message. Expected start of expression. Okay, fair enough. We don't know how to start expressions with this. We'll get there. All right. Yeah, down here. So factor, if it doesn't recognize what it's got, it does that. And we have a case of a predefined. All right. However, we're due for a break. So let's take a 3-minute break and we'll come back and get these functions parsing. I don't think that'll be too bad. And then we'll fix that type issue because I think our functions are going to need to know their type somewhere. All right. See you in a bit. Hey, welcome back. Alrighty. So we're to the point where we want to parse our expressions. And I don't know, this print. Once again, we're going to have to deal with print. Where's print? Print statement. You know, I think we can simplify this. I think, let's find the other place that does this. Start expression. Yeah. You know, if you call print with an expression, okay, let's get the thing in and then deal with print. But we don't need to do that step up there where we check. We can just look for in a line. All right. So our case is we're seeing a predefined case.predefined let name and let just, I guess it was just a name, right? Let name equal token. Okay. So if we see case predefined, let's get our token. Okay, with the name. Okay. We want to consume that token. All right. And then we're expecting, well, let's just make a predefined function call. All right. Predefined function call. I don't think we need any arguments. Expression. And it throws, which means this one's a try. Oh, I guess we can pass the name in. Okay. Okay, so we're clearly seeing we're at the token, the name, the predefined function name. Okay, we saved the name. Yeah. All right, and then we're looking for a left parenthesis. Yeah, it's close. Left parend and missing left parend. We maybe could consolidate that. Okay. You know, I think maybe our def. Maybe missing left parend is the right name there. Excuse me. And we'll put that up with the right parend. Missing left, missing right. Okay, and then down the bottom. Okay, let's see. So we've eaten the function name, the left parenthesis. We're going to do an expression. Let expression equal expression. And then we're going to return. Oh, we should get a try here somewhere. Here we go. Okay. Now we're at the point where we've got the name of the function, we got the expression, we need to do a function call. All right. And we got predefined. The string is the name and the expression is the expr. Okay, he's catching up. He's catching up. All right, let's see how we're doing. I believe we're all set. Oh, we didn't hear right parend. What error did we get here? Expected start of expression. Oh, that's from our print. Okay. Right. think we'll still get that same error. Yeah, that's coming from our print. Let's fix that. Print statement. Okay, so I think all this switch here, because if if you have an end of line, then you're done. Okay. If it's not an end of line, then you gotta get the value. And we don't handle multiple values yet, but we will. So I think basically, if the token is end of line, then we can return basically this with an empty list. Parse.print with an empty list. Okay. Otherwise, we're peeking in to say, are you one of these things that you're supposed to be? If so, let's try expression. Well, if you call expression and you're not one of those things, down at the bottom, when it gets into factor, it'll say, hey, I didn't have one of those things. Okay. And all right, I can move this down too. Okay, so I think this is anticipating the loop, but anyway, this stuff can go away. Value equals try expression, values append. This stuff goes away. And let's format. Okay, I messed something up. Nope, it messed something up. Print statement. Okay, if it's followed print followed by end of line, then we just return that empty thing. Otherwise, we grab an expression and append it to that list, and then return that list with just the one thing. Okay, so let's make sure our to-do has print multiple values in it as a goal. Print multiple expressions. Okay. Yeah. So I think that should make things better. I don't know why that didn't occur to me earlier, because we've been hit by it probably half the time we've added a new factor type and haven't matched it. Okay, so anyway, we have our call now, so that's cool. And it's at the bottom here, right? So we're calling predefined with the name and the expression. Okay, and then our let's see, what we had a type issue, right? What's the type of this thing? Well, right now all functions are returning ints, and we just say that. But let's add a to-do. How about predefined numeric functions and predefined string functions? And actually, I'll defer this one. And I guess we're working on this now. Okay, so function call. All right, so we need to interpret predefined name calling expression. Okay, and let's get to interpreter and interpreter tests. Okay. You know what? I said we were going to do some cleanup first. I think we're going to do that first. All right. Let's make a helper. Okay. This is a check. I call it check. I usually say test for the test and check for the helpers. Check, I guess, parsing. And it's going to take program of string, and it's going to return, what do we call it? Parse. Expected of parse. Okay, so we'll let the line equal the program. Which I think I can just do this line. Results and expected with no errors. Did I not do this once already? Check expression, check error. No, I did not, apparently. All right, let's put this up there with those. And I saw another check down here for relationals. And I think this one is kind of, I don't know, I want that to be first for whatever reason. Again, I try and tell a story in a sense, and I think check parsing the whole thing or check expressions or relationals. I think maybe error is fundamental too. Maybe even more fundamental than working. Because there's a lot more code for errors than the rest. All right. Expected error. All right. So I think this thing is really check parsing. Of that and that. Okay. It's still a little long, but there's no way around it if I'm going to make this format look at all nice. Okay. I guess it'll look a little better if it was full out. Okay. This should pass. And now let's find the other program ones that are kind of the same. Okay, here's another one. Okay, relationals. As usual, I've waited too long on this. I keep saying I'm going to get this parameterized testing thing. I've been very back burner on. But I don't know. I like bumping through the interpreter, but the fact is we really could benefit from it. And I guess I should have been checking these in before because we did our parser changes. What did we do? Lexer? Yeah, we did a little bit. Okay, let me cancel this. Let's run all tests. Then I'll finish the refactoring. Okay, so we add support for SQR, first predefined function in lexer and parser. That's more like a check error, isn't it? Why is it not doing that? We didn't check for errors here. Over here. So my test is now testing a little more, which is a good thing. I missed one. I guess so. The other one on my mind, um, I think, we've got this distinction between expression and node. I wonder if that has grown up enough that that should be separate files. Parsing an expression versus parsing the rest. Because it's got all these, well, this has got a fair bit of chunks in it. It's big enough to be its own thing as well. Let me add a to-do there. Um, this is a split. Something like that. All right. Okay, so we did not get to interpret yet. So let's look at interpreter. We've just hard-coded how do you do a predefined function call? Well, you just return 99, minus 99. Alrighty. So if we do func test call sqr, see a pattern here too, don't we? All right. So if we 25 print sqr of 4, then we expect 2 to be our output. Alrighty. And that should fail, of course. Hopefully with a minus 99. Yay. Okay. All right. So, well, let's start easy. This is the expression to evaluate. Let operand equal that. So we're going to evaluate the right-hand side. And let's return value.number. Square root of the square root of operand. Oops. Operand dot as float. Okay, so we evaluate the expression, take its floating point number, return the square root, and wrap it up in a number class. Okay, and this should pass. All right, and this technique I'm using now is kind of fake it till you make it sort of thing. So I'm putting in more and more mechanism that is compatible with what we've done, but it's not necessarily driven by what we've done. All right, but I know I'm going to add another function that's ASC or whatever other functions they had, int or random or something. And so the fact is I'm not even looking at the function, right? I should be looking at the function. So somewhere we need a map that gets us from the predefined function name to the square root. And I don't know how we're going to know. Well, this comes back to the type. Right. So if If my store held functions, what would that look like? Yeah, what would that be? So we would have to be value. The function would have to be a value of some sort. And I think this is like, it's got to have its type in there somewhere as well. And that's moderately complicated. In general, we had, let's get back to that list. Yeah, so these are all number to number, the numeric functions. But this can be string to number, number to string, string and number to string, string number to string, string number to string, string to int, or number, you know, it's got a bunch of variations. Right now we just have the one. So if there were a function, all right. So if the store held the function, what would that look like? Well, we'd be saying like, let function equal evaluate. Well, what does this thing look up, right? It looks up our store is it token or string? A string to value. Okay, so the function name, evaluate, well, it's really store subname. And then we would call the function. How would that work? Okay, well, let's try getting it there. So we want to make a value is a function. Where's value defined? Okay, value. And it's going to be on the type. All right, let's go back to type. Right, so this notion here, we had a function being a type, right? We would take a list of types, which is the arguments, and return a type. I think that's legit. How do we make that happen? Well, I guess we just define it. Let me pull array down since we're not doing that one yet. I don't think this is far off. I think argument types to return types, and we don't have a void function. Our functions all return something in every case, so we don't have to worry about void. If we had to, we would add case void. All right. But I think that's okay. Let's see if anybody complains now. Does anybody switch on type? I think we saw that here, right? Default value. So let's find who calls this. Should be a test. No. Okay, let's add one. This is a lookup. I'm going to return a 0 for now. I don't think it's the right answer in the long run. Okay, so if we call type dot function of float to float, and we get its default value. This is almost too helpful sometimes. Of that, we're going to say it's value dot number 0. Okay. Let's build that. Oh, you can't build. Okay. Okay. So if you recall, the default value was used in the lookups. Okay, so when you're a variable of this type, we don't have variables that can hold functions in BASIC. At least these old BASICs. I don't know what they do now. It just wasn't a thing back then with BASIC, and not for a long time. So this is more to satisfy this case and not complicate things. What I said, I could see a value that's like, an error or unknown or something like that. And if we did that, then that would, the function should probably be that. Okay. All right. So now function equals store subname. Okay. Yeah. So that's right. Yeah, we could probably work out a definition of a function that printed an error of some sort. Okay, but I'm just going to make this that for now and make sure this type is value. Okay, so we have the value. I guess we want to like call it. All right. So we got function is store of name. So we've looked up the function, we've evaluated the expression, and now we want to apply the function to the expression. Okay, and function is whatever's in the store. Well, we better put something in the store. All right. here's the store, and this thing's going to grow up too. But for now, SQR maps to some value dot function. Do we have that? Where's value? Type has it. Yeah. Value does not have a function. Okay, let's add that. Function. What is going to go on there? Let's start with nothing. All right. Value.function. What's the problem? Fix that, whatever that meant. Okay, this can go like that. Okay, so square root is a function. Cannot convert value of type void to value to expected dictionary type value. Void to value. Oh. Okay. So we look up this. We don't get a particular function. Okay, we don't use it. Right. Okay. So I want to do some sort of apply. Right. So what I want to say is function dot apply. We're going to have to give it operand. Well, I'm going to give it an array of stuff, and it's going to come back all perfect. So operand. Okay, now I'm passing in a value. That's a good thing, because my function doesn't know anything about it. Okay, so if I wanted to do that, function.apply. Well, I don't have an apply method. And let's copy this because we'll need it in there. No, remember apply. So let's get back up to function. Up here. Okay. We're going to add an apply. It's going to take a list of values, arguments, and it returns a value. Okay, and then something like this. Let's say return value.number square root arg sub 0 as float. All right. How about just func? Yeah. All right. Insert func. Yes. Okay. What's going on down here? Initialized value function never used. And I'm not using it here. Okay. Switch must be exhaustive. Okay. Bool to float. And interpreter. Format. Okay. Let me see who does bool to float. Okay. That's all here. Let's just turn this into a 0. Is it 2 things? I don't know what he's still complaining about. Pattern with associated values. Okay, x is a value. And a value. Case function. Oh, we said nothing there. Okay. We're still not taking arguments yet. Okay, but what I'm saying here is I don't really think if you compare something to a function name, let's just say it's a false, okay? And then the second one was the format. Again, I don't think this can happen, but case function, let's just return function. Maybe even bracketed. Okay. Right. Let's run tests again. So this thing, I'm kind of trying to grow this thing. I don't know if I'm jumping too far. All right. So let's go down. Let's evaluate function. Okay, so I've moved that up basically. All right, so what do? If it's a predefined function with a name and an expression, then look up the function, evaluate the expression, and apply the function to the operand. Operands in this case. Okay. Now we know this is too simple. Okay, so apply always. Just always does square root, right? We know that's not good enough. Somewhere up here, what I'd expect to do here, I really think this should somehow I should just be able to pass in the square root function. Okay, but if I make this it's almost like the argument types or something. I don't know. Square root is number to number. All right, float to float in our case in Swift. And value.function can certainly default to that, but Okay, so if I did this square root, okay, I'm saying it should know the system function that it's trying to be, and it, in this case, it's an actual function. Okay, so let's give function. But the problem is when I have these other ones that return different types or different things, right? They're going to be they're not going to be so simple. I'm getting down to my apply call again. So I think a function is going to take arbitrary arguments. Right. So my functions I'm applying, they really are values to values functions. And this is a float to float. Okay, so I think what I want to say is function takes values to values. I guess what I would like is something that can wrap a system function, a Swift function into a value function. Okay, so if I had well, yeah, let's do this. If I had a function, I'm going to call it function number to number. And it takes a Swift function, which is float to float. And it returns what? Is it returning a value? Well, no, it's returning a function that is value to value. I think that's what I'm after. All right. Okay, it can be written. All right, that's something. Single argument. Okay, float to float. Okay, so if I format this a little better. Okay, it's a little bit non-standard formatting, but I'm trying to make sense of it here. All right, so you give me a float to float function. I'll give you a values to values function. Okay. And this then is a function you can call. Oh my gosh. I can tell I'm confusing myself. Well, let's see what this looks like if I did this. Fn to n of square root. I mean, if I called it with something, let me set that aside. I'm stumbling around a little. Okay, so what if I had a value square root function? All right, and it takes an array of values and it takes args is array of value, and it produces a value. Okay, and so let's use that here. Value square root. And what it does is what we had elsewhere, right? Apply. Okay. You give me the arguments. I'll peel off the first one and treat it as a float. Okay. And this function, we will need to give this to value. Value function, it needs to take a value to value. Is it going to need parens? Yes. Okay. Type value does not conform to equatable. Oh dear. I really don't want to do this. All right, what's going on? So I'm saying values really are functions. They take lists of values and they return values. And now it's complaining because my left hand, my equals doesn't work because it doesn't know how to make function equality. All right, so let's make some function. Well, we can't do it either. But what I can do is switch on LHS RHS. I think I can say dot number of let float one dot number let oops. Okay. Oh, I did this again. I think I can do this. Okay, it's a little awkward, but okay. Hey, on life support, can squirrels raise a value? Yeah, I think that's gonna yeah, that's kind of what we got to do. So first element is the predefined function. Yes. Second, the return type. Yeah, I think our type structure has to grow to support these functions of various types. So I think that's where I'm heading. I feel like I'm getting a little lost, but this to me, can I use instant method within property? Oh dear. Okay. Um yeah, so raise a value. Yeah, what I was envisioning, and it still may come to pass, is this this sort of defines a number to number function like square and whatever else we got, pause and exp and sign and so on. Um, but I think that's to save me from writing this stuff, which unwraps the first argument, calls the function, and wraps the result. All right, I want to do that at the Swift level and have that go. But this, I guess I gotta have to insert this later. Um, let's do it down here. Hopefully that's legal. Okay. Missing return. Let's comment this out for now. I know that can be done. I just am not getting it right. All right. And this, yeah, this doesn't really belong in this class either, for that matter. But yeah, maybe I don't know. Maybe I'm just taking too big a step here. Okay, so let's see. Where are we? Okay, value with function. I think that's okay. We got to apply. That's defaulting. Okay, yeah, that's what should be calling this function. Yeah, yeah. Um, I mean, I think we can build some of this into the structure like this. So I don't think I have to. In the end, I don't think I have to be explicit about it. I don't think I have to call it out separately. Yeah. So in Swift, the this is the sorry, the store is a dictionary type. So it maps string to, in our case, it's to value, and so we've got to define a value to manage these things. So that's why I'm putting this function in here. The types, I don't. I guess I'm not clear that we'll need them. Um, because if I'm saying there's only one type of function, which is give me a list of operands and return a value, which accommodates um, accommodates the simple ones we're doing now, like square root, and it also accommodates mid dollar x dollar ij because the function takes a string int. Those are all three values, and it returns a value which is actually a string. Um, that should all just kind of fall out. So I'm hoping I don't have to explicitly represent those types, that I can do it implicitly from this. Um, yeah, yeah. But yeah, I mean, I think we're on a similar track anyway. I hope. Okay, so now I think the value that I'm calling, right? This apply. Somebody's got a function for me that passed in this function. Okay, so I should be able to get that field out. Okay, so the case is function, and we'll call it let fn equals self. So if I don't see it, I'm going to print apply called on non-function, and that's kind of a not going to happen thing. All our our semantic analysis from earlier should make it the case that you're never calling. All we ever do is pass in a predefined, so there's no chance it'll happen. We'll just return value.string with that. Okay. Okay, so in principle that can't happen. Now we've got this function here, which is the one we wrapped. Let's find it again. Value square root. Yeah. Well, you won't have to follow along and know that my Swift knowledge is kind of limited, but it's very spotty is the thing, and I tend to forget how to do stuff, but I get some of the principles anyway. Let's see. So I've got this value square root function. I want to actually call that now instead of hard coding square root here. Okay, so function. Now this is where I messed up. Oh yeah, no, I'm not. It I should just be able to call function of args. It returns a value. It takes values and returns a value. So I'm hoping this now calls my square root function. Okay, and let's see. Can we tell from here? Where's this? This is the one. Yeah. So this should still work. All right. Yeah. So we actually made some progress there. Okay. I'm feeling better. It's a little bit tangled, but I think it's all right. Okay. So we're plugging in, when we have for a function, we're gonna have a pile of system defined functions like square root and ASC and whatever they all are. They are all going to be values, and the values say you got to define it in a way to take a list of values, the operator or the arguments, and return another value. Okay, and when that's looked up down here, evaluate of a predefined, we're going to go dig up that function from the store, and now we have a function. It contains the system function in it. You're going to apply that function. Okay, so let's go up to apply. Notice the list of operands, and then the return value is returned. So let's go apply. We got the value in the store. It takes a bunch of arguments, values, and it returns a value. And the work, well, we make sure it's still a function, but we know it is. And we apply the function to the arguments. That gives us a value, and we're back. Okay, so we've closed the loop on that. And so I think now what I want to do, and maybe this is just not quite this function. So in my initialization, I put value square root because this does that. Let's add a second function and see what happens. I don't know. That's quite a few steps, but I think what it's going to say is we've got stuff in good shape now, and I'm going to pick whatever the easiest one is. Sine. Yeah, let's do sine. Oh, that's a lie. Pause. Oh, interesting. Okay, so yeah, we'll just take sine because I know sine works. All right, so the way to add this thing is we have to add it to the lexer. And I'll just alphabetize these and put a comma in. Okay, so we can handle the sine function there. I guess I'll do something similar. Sine of 0, and I forget my trig. Is sine of 0 0 and sine of cosine is pi over 2 or something? I can't remember. Okay. I'm going to trust that the system will know sine better than I will. All right. This function basically should blow up because we don't have it in our list yet. And I think we ended up with some console output maybe. Unexpected nil, unwrapping an optional. Yeah, so yeah, here we said that function will be there because we'll guarantee it is, and it wasn't because we didn't put it there. All right, so we need to add a sine function here. And value square root won't do it, right? We need value sine. Where is that? Okay. Value sine, and it takes sine of the arguments, and that should be defined standard math function kind of thing. Okay. And so the test should run now. All right. So adding a new function is not too hard, but we have to define the function, to take values instead of floating point numbers that these things take. So this is where I'm trying to do this thing, and I maybe right. So I'm trying to return a function. So I've got to return a function, I guess. So can I define it inside here? Well, I can define a lambda, right? So I'm going to return a closure. Okay. And it takes an array of values in, okay. I should be able to say function. It takes a function, right? So I should be able to take the function applied to value sub 0. All right, is that Is that right? Okay, so, oh, cannot. Float to, oh, I gotta do, I gotta do basically this stuff. So I'll take values sub 0, well, let's call them args, just for consistency. Arg sub 0, and this is n to n, number to number, so as float, and then the result I'm going to wrap in a value.number of function. Okay, so I'm going to take the first, it's just not escaping. Oh, not escaping parameter fn. Oh, there's a way to do this. Is it at escaping? No. Only apply to types, not declarations. Escaping. Is that applied to a type? Okay, maybe I'm okay here. All right, so if you pass me a function like sine that takes float to float, I'm going to turn it into a closure, this in brackets here, that takes value arguments and returns a value. And the way I'm going to do that is I'm going to unwrap the value into a float, call your function that takes a float and returns a float, and then that return float gets wrapped in a value. Okay, I believe I've got this now. And so down here, this is value.function. Well, it's my fn to n of square root, okay, which is the system function. And it's just the name of the function, not anything else. And then this one is function n to n of sine. Okay, and I think these tests are going to still run. Let me just run the whole batch. I'm so confident, I guess. Getting down to the end here. Okay. Yeah, so this means I don't need these things anymore. Nobody's calling them now. Now my naming and stuff, I feel like it's getting a little crowded in here, but you give me a good old system function that's float to float, and I will convert it into a values to value by doing this. And then I'm going to need another one. Let's tackle a different one. I don't know, those are all, well, maybe a string one. Length of a string. Okay, so I'm going to define, well, let's see, do I want to do that here? Yeah, let's add a string function. Okay, so back in our lexer, and I'm kind of assuming I trust myself to just do these properly. Len, it's predefined with its own name. Okay, and so it'll parse, and then down in the interpreter, I've got to add one that handles that. So let's do that. Okay, so this is len print len of a quoted string ABC. Okay, let's len, and it's right parenthesis. Okay, and the length of ABC should be 3. Okay, and this should fail. We don't have a len function defined in here. Okay, so it's going to blow up in the debugger. Yeah. Okay, because again, we're looking up a function we said would exist, and it doesn't exist. All right, so now I'm going to say len equals, it's a value.function because I want functions, and I want one that takes string to number of count, I think. Well, that's not a function. $0.count. Okay, so it's a string function. You give it a string, it produces a value, a numeric value, and it's probably got to be float of that. Okay, so I can do these inline kind of things, but I don't have fs2n yet. So string to number, this one takes a string, produces a float. Okay, so we'll take arg sub 0 dot as string and apply our function to the string. Okay, so I think this should work. So they're not bad. Once you get one in, it should kind of work. I think our parser, yeah, there we go. Okay. This is a little hard to understand, I guess. That's the thing. It's sort of this functional, I mean, I'm making a chain kind of from my Swift domain, a string to float function. I sure wish it was values to value, and this little helper function takes care of that. So let's go ahead and add all the other, well, the ones we can add. Abs. I'm going to add the names in the lexer anyway. Let's get that done. And I don't feel obligated to test them all like one at a time, because I'm just testing that the table has the name in the table kind of thing. So I don't think it's an issue. All right. So abs, they're not really alphabetized. Abs int rand signum SGN sine cos tangent signum. I'm gonna get the names in first. Oh, I've already got sine. This is how you mess them up too, right? Tangent ATN. Trying to think if I've ever written a program using arctangent. I kind of doubt it. Square root. Tab is funny. We'll deal with these. User is letting you put assembly code in. We're not going to support that one. EXP, which is okay. So let's catch these up. Signum, cos, tan, arctan, tab, user, exp, free log pause space. Okay. Oh, interesting. These ones that are only in print statements, I don't know. We don't necessarily need to enforce that, but okay. ASC. It's a pity I have to do them both. Repeat this, but I don't think I have a way around it. CHR, left, right, and mid. Right. CHR dollar, left dollar, right dollar, mid dollar, len. I think we did that. STR dollar and val. Okay. ASC, CHR dollar, left dollar. Val. Oh yeah, good point. Thank you. Yeah. Okay. Let's sort these. I don't think there's a predefined, is there? Sort. Oh no, too bad. You would think there'd be a service or something. I think I'm missing a comma somewhere, but there it is. Okay, just group these a little bit. Okay, let's run these. Good. All right. Now I don't know how much do I want to? Yeah, like what do I want to do today? Predefined numeric functions, predefined string functions. Okay. I just think it's boring to to put, abs and sine and cosine and but that's kind of the only way to do it. Except I could switch back to the other function call thing. Maybe it would be good to. Okay, so I've got these all covered, the one-to-ones, but I need a function that is string to numeric. I got that, but I need numeric to string. Okay, so let's fill in that. And I don't think there's a shortcut way to do this. Okay, numeric to string. Okay, so it takes a float and it produces a string. Okay, so this is as float and this is string. Okay, this is string number to string. These names aren't super memorable, are they? So string, let's say float to string. All right. And then arg sub 0 is a string. Arg sub 1 is a float. And this result is a string. Oh, semicolon, yeah. Comma. All right. That covers these two. And then string number to string. And I think these are covered by the others. String number to string. String number. Args1 is float. Args2 is float. And the result is a string. Okay, so I think we've got the basic structure for these. Let's run tests. Okay. And I'll say remaining predefined numeric functions. All right, and remaining. The list gets smaller. Let's see. I think I want to do some cleanup and breaking out here, though. I'm getting so buried in these things. All right. I think these are related to value. And I think it's time to pull value out. Okay, so yeah, let's take all that. Okay. I need to commit. Okay, so handle predefined functions. We lex them all, but don't interpret them all. Okay. Now let's make value. Well, right now it's an interpreter. New file. Okay, value equatable, all those functions. I don't need these. Why is it? Oh, okay. I don't want these to be file private anymore. And then we got to get them out of here. right, and let's do a clean. I guess it wouldn't hurt to do that either. All right, and run all tests. Hopefully they can find everything. That's what it's. Cannot find fn2n. Maybe they belong. I don't know. Do they need to be static? Maybe they just need to be public. I feel like I'm not. Result uses an internal type. Oh, well, let's make this public. It's funny, it didn't. Value.swift, line 11. Code sign. I don't know what that's wanting. Do I have to sign it if I'm doing public? That seems weird. Okay, good. Close that. All right, so we've okay, I think that's a good thing. And then I wish I could find a way to make these more unified, but I don't think I can. All right, interpreter. Type is still there, bool to float. Okay. We got predefined. All right. So this let's create this default default value function. Let's see. Function. I think what did I do there? Okay. Yeah, this default value thing. I think maybe a string would be a better choice. Let's do that. All right, I think I might have had a test for that. I believe our last interpreter test, maybe. Right. This should be string. I think I can get the name out too. Type function, default value. No, I don't think I can. Okay. Give function a string default value instead of a number. So I'm just going to cheat a little bit and temporarily change a test to use a function we don't support, like cosine. And I don't even have the right type here. I think this should get the undefined function value coming back or something. Yeah. I haven't used it. That's the problem. No, that's not helping anything. Okay, let's undo that. All right. This is kind of an optional thing because theoretically it can't happen, but let's add just a note to handle the case of a missing predefined function. Maybe that's better done before we actually do them. Okay, def user-defined functions. I kind of want to pick up there next time. Okay, so I think what we've done is we've got the structure for all the predefined functions is basically there. The only piece I'm a little worried we're missing. Yeah, because what happens if you call mid dollar, but you give it, instead of a string, you give it a number? I don't think anything's enforcing that right now. And somewhere we need to record that type. I think that's what, oh, sorry, I forgot the name. On life support. I think that's kind of what you were getting at, right? That we don't have those types explicitly listed somewhere. So somebody, like, how's the caller going to know that it's got the right thing or not? Yeah, so there's some gap there for that. Let's run the test, make sure I put everything back. Yeah, so how can we enforce that? The fact that mid dollar needs that. Normally we've done that in the parser, and I don't know if that's. I guess that would require us pushing our functions back, some sort of definition back into the parser that has this type, and maybe it's even in our token. We could look at doing that as well. That mid dollar comes back as something of type string int to string, but yeah, that's going to have to. We shouldn't let you try and interpret something that we know is going to have the wrong types, and the the type of this has been defined for 45 or 55 or 65 years at this point. So it doesn't seem like we should just let that run till wait till runtime to find out, like, hey, you said you were going to give me a float and you gave me an int or something, or a string. So we'll do that. So my plan for next week is that I will broadcast Monday, um, and Monday to Friday, same time each day, 9 to 11:30 Central Time, 10 to 12:30 Eastern Time, and 3 to 5:30 UTC. And if you're on another one, I'll let you work it out from there. But we will pick up there. I think we'll get our user-defined functions working, and then we'll kind of wrap up on the functions. Let's see. Always have an array of length, a function, and return type. Skipped index 2 and through the end to validate. Yeah, Swift doesn't really support mixed arrays, so we have to kind of, um, we'll have to kind of split things up a little. But we we don't have variable arguments in BASIC either, so we don't have to worry too much. The lengths are always fixed according to the function name. But skipped index to iterate through the end to validate. Yeah, we got to do something like that. We don't even support function calls with commas yet, so in a sense, it's uh, we got some work to do. But yeah. So uh, uh, if you, well, this is kind of like our value type is really to get around that. So because I can't put a number and a string in the same array, I wrap them up in this value type that's got specific cases for the two things, and then I can put values in an array, and each value can be of a different type. Basically, it's a different case on the enum, because let's see, do we have it here? It's in value. The enums in Swift, they let you attach these extra fields, so they're pretty sophisticated that way. It's some people call it sum types because you sort of get independent things you're adding in possibilities. But yeah, so I've basically wrapped up the types like that, so I can create a pseudo mixed array of different types. All right, PHP and JavaScript. Yeah, they don't care. I don't mind it, but it does give you stuff where you have to do this, like break out explicit cases and decode it a bit. And that's kind of these as floats. I'm just sort of like saying, well, there are situations where I know it really is a float, and I just want to get the value out, but there's no kind of default way to do that, unfortunately. At least if there is, I haven't seen it. All right. Well, thanks for joining today, and I hope I catch you in the future. So have a good weekend and a nice holiday if you're celebrating that. Take care. Bye-bye.